the data-array with a 2-dimension on the last dimension, with a 2-dimension on the last shape. So now you can see what I'm going to do is I'm going to create a new array with all 0 values, and the shape of the new array y-1 is 6 and 2. So, and after I create this new array, what I'm going to do is for each of the row of the new array, so you can see I actually use a for loop in range from 0 to 6 because 6 is a row of this new array. So for each of the row, I'm actually calling the each of the row with the new array and redefine the value on that row to the data-arrays value. So what I'm going to do is I will give this data-arrays last 2 columns value to each of the row. So when I actually do that, you can see if I run that, you can see the new array is actually becoming initially going to be all zeros for all the values, and now it's actually perfectly given the values of the last 2 the first 2 columns of the data hyphen array, because it's actually calling from 0 to 2. 0 from 2 to 2 means that it starts with 0 and ending at 2, so 0 and 1 only. So after that, actually what I want to do is now I have array, but I want to actually switch the array back to the data frame. So what I will do is just calling a function called pandas data frame function with the array here, and then I define the columns of the array is B and C, because at here this column is from B, because initially the data hyphen the first column is B, you can see from here, and second is C, and third is D. And now I redefine the header of the columns B and C. Now you have your new data frame called y-1df with 2 columns, column B and C only. So that's what we do with NumPy and also the pandas data frame, and we transform the data frame to NumPy to this data frame by using slicing and indexing on each of them, and plus I use a for loop to help me to do the job. So by any of you who doesn't familiar to this part, please watch this video and play this syntax by yourself and try to practice more and more, and you will be handy for doing this sort of the tasks for your own. And because at first we define 2 functions, which is a Sigmoid function and reverse Sigmoid function. So just give you a feeling of what is a Sigmoid function and how we actually use it. So it's quite simple. So you can just call Sigmoid with a certain variables as an input you put into. So now I'm trying to print out the transformation of the -10 and a 10 after we use the Sigmoid function. You can see that the -10 is quite small after transformation. You get it. It's really a number that close to 0, and for Sigmoid 10 it's actually close to 1, and that means if you give them a large number and small number, they pretty much convert them to a range of 0 to 1. And this is the link of how you actually find the Sigmoid function and also the syntax of them. And now I have a new data frame called y-1di. But what I'm going to do is for each of the column B and C, I'm trying to column B particularly, I'm trying to use this Sigmoid function to convert each of these values to the values after the Sigmoid function. So what I'm going to do is I can actually just use a syntax of y-1df, which is data frame, .b, that means the column series, and then I use the apply function. And apply means that I'm going to apply a method for each of the components in that series, which each of the value here for the column B. And what we're going to do with apply is I use a lambda function, and the lambda function will actually call a Sigmoid function for each of the values to do the transformation. So by doing this, you can see that what I'm going to do is I actually just calling out the column B from the data frame of y-1df, and then I'm going to transfer each of the value in the column B by using the Sigmoid function. And after I print out the results, you can see that they give you 6 values because you have 6 values in the column B. And after you transform these values by using Sigmoid function, the result is actually become like this. So 8 become 0.99, and 4 become 0.98, and 1 become 0.79. Sorry, 73. So this is how we actually use apply with lambda. So this is a very common sort of syntax by actually transferring or transformation, doing the data transformation in the column wise. And for any of you who doesn't really know how to use apply with lambda, please play with this syntax for your own and do some of the exercise, and if you got a feeling and understanding of what is lambda function and how you actually use apply. And and another thing I want to mention here is because you use apply, so as you can see, apply is actually quite similar to for loops. So what it does is actually to apply the same method for each of the values in the column. So you can do the same thing by using for loops, but in pandas we highly recommend you use apply with a lambda function because this is really absent on the usage of the RAMs and the computing. So that's how we actually do the iteration of the transformation in column wise. And please actually just keep in mind apply with lambda, and that's how we do with the transformation on the column wise of the value. And now we finish this part, and we actually start with something called a new function on the time series on the series, which is a df with a, because initially our data frame is df and your a columns is this column. And what I'm trying to do is I'm going to count the values in the column A. So this is column A. You can see the values, and you have some duplicates on the values, zeros, 0 to 0. And let me do a value count and see what's happening here. As you can see that 0 has been appeared twice, so you can see the count of 0 is 2, and the rest of them count is 1. And now we actually start learning how to use group by, and let's look with our initial data frames here, which is A, B, C, D with the 6 rows. And what if I try to group my B and A by using B? So the meaning of that is, so let me just run that and we'll talk about it. So the meaning of that is for any of the values in A, and I'm looking for the column B, if the column B has the value on column B has been appeared twice in the column A, and we're saying that the column A's count on grouping column B is 2. So what does it mean is you can see 1489, that's the unique number come from the column B. So 1489, there's no any other numbers. And then they do a count on the A columns value and see how many how many ones has been appeared in column A, so only 1, how many nines, so 2, how many eights, 2, how many fours is 1. So now you have a new sort of a series from this sort of syntax is 1 only 1 times in the count of the column A, and 4 have 1 times in columns of A, but 8 and 9 have 2 times count in the column A. And you can not only do the single sort of the group by, but also you can do a multiple column group by using a group by with 2 columns syntax. And of course you can use a different sort of the aggregation, not just count but also use a main. So if you do that, and this is going to tell you that if I actually just group B and C together, and for all the values that meet these 2 terms here, I'm actually calculate the mean value of that. And if you calculate for the columns for the column B when the value is 1, and column C the value is 5, and the mean value of all the A columns meet this condition is 1. Alright, so and for the 9 and 5, then that's going to be the same, that when the value in the column B equals 9 and the value in columns value in the column C equals 5, and the mean value of A, if you actually do a mean value, that's 9. Let's have a look. So B equals 9 and C equals 5. So you can see only one row calls out, which is this, and the mean value of 9 is 9. So that's how we actually get this. Okay, and similarly, we can do a group by B and with BC, and group by B with BA. Let's run these two. And by the way, what we try to get is the mean value. All right. So now you have two group by results, and what we can do is actually create a data frame by each of the results on the group by. You can do in the syntax like this: pd.data frame and group by, and after you run. And now what I'm going to do is I use the pandas concate function to actually merge or concate these two data frames together on the axis of one. Axis 1 means the column wise. So what I can get is, you can see two data frames. I put them together like this. Because all of these two are grouped by B, so you have the same index. So with the same index, you can actually put these two columns together. All right. And furthermore, you can do some filtering on this data set to do some of the selection by own preference. And now I'm actually going to talk a little bit into NLTK, and that's actually related to the practice too. And NLTK is a library for the natural language processing. And before you use that, you should download some of the libraries of the stopping words, and they will ask you to actually download certain libraries, and you can use this syntax to download. And after you call this all sort of the functions and modules part, there's no sort of the explanation of each of them. It's more like, for example, tokenize is actually try to ask you to actually run a tokenize on the data. So for example, a good example here is if I have a data with the synthesis of this. So for example, all work have no play makes Jack a boy, all work has all work and no play. So tokenize is I try to break this synthesis into the word only. So as you can see, if I use the library of the NLTK tokenize, and then I call the word tokenize, that means in the word level of the synthesis actually break into a list of the words that actually make up this synthesis. Alright, so more explanation on NLTK, you can actually go through these links, and you can find out the very comprehensive introduction on the NLTK. And good luck for your learning, good luck for your assignment. Hopefully this video will give you a little bit help on studying, and perhaps you will find several hints for your assignment 1.